Thanks for joining us for another episode of DPC Radio. This episode was recorded live in Amsterdam at the Dutch PHP Conference 2012. For more information about the Dutch PHP Conference, visit our website, phpconference.nl.
All right, welcome to Cranking Nginx to 11. So this is me. My name is Helgi. I co-founded Orchestra.io. We're sponsoring the conference. It's a PHP platform as a service. Engineered bought us. I'm a paired developer. I'm from Iceland originally. And if you want to heckle me during the talk for whatever reason or ask me questions, you can just tweet me at @h. And it's not a big deal. I'll try to answer you if I can actually find it. So, Nginx. Who here actually uses Nginx to any extent? All right. A good chunk of people. So I find there's not a heck of a lot of people that actually use it and know what it's about. I realized that the description says this is supposed to be a really advanced talk about all the crazy cool features, but the more and more I talk to people, I realized people just don't know the fundamentals of Nginx. So I'll be going through some of the fundamentals, and depending on how quickly we can get through things, at the end of the slide deck, there's some really cool stuff, and I'll try to talk about that. But so just bear with me for the people that may not be familiar with Nginx. So Nginx is a web server, a proxy, a caching server, a mail proxy, and a few other things. So Nginx is just not a web server. It can do so many other cool things. But we have to start our journey somewhere. So let's take the journey to 11. Let's crank it up to 11 slowly. So when you're actually doing stuff with Nginx, you have to obviously change the configuration, and that's always kind of a testy moment. You have to figure out, am I doing the right thing, or am I going to break the website just by changing this configuration? So the best thing you can do is always run config test before doing anything, before putting it live. So it will tell you this is wrong, there's a warning here, you need to do something better. But that's not really the coolest bit about when you're tweaking Nginx. It's realizing how the reload functionality works. So if you're using Ubuntu or similar, you'd be using service Nginx reload, service Nginx config test. So what the reload actually does, it reloads the configuration, but it does it by doing a really specific process. So Nginx works in a way where there are master processes and workers underneath. When you reload a configuration, you need to realize that it's actually reloading in a way where it starts new masters and new workers and starts closing down connections for the old workers. So if you have any connected clients, any customers connected to your website, it will keep serving them from the old configuration. And the new one is just being reloaded in on the fly without a problem. So you're not restarting Nginx as such, but you're still reloading all the workers. You're starting up new workers and killing off the old ones. So it's really essential to know that kind of stuff. But even more impressive, the upgrade process in Nginx, you can actually do live upgrades of the executables. So if I'm updating Nginx and I go, I need to update this stuff, it will do the same process, but do a bit more complicated. So what happens is that it starts up a new master and new workers, and it starts feeding traffic from there if it can, but it keeps around the old workers and starts gracefully shutting them down. But it keeps the old master around until it feels like it has actually upgraded Nginx and there are no problems. If that fails, it can actually tell the old master, I want the old binary again. So it can actually do live upgrades on the web server without problems. And that just kind of shows the flexibility of Nginx. The ability to upgrade a binary on the fly, on a live server, without downtime is incredible. But when we're dealing with Nginx configuration, most things are going to be location blocks. They're the foundation of most things that we'll do going forward. So understanding what a location block can do for you is quite essential to how you think about configuration, how you do all the cool stuff. So here's a really common block that you would see. It's trying to figure out, is the URL, does it exist? Does the directory version exist? Otherwise, we're just piping it into index.php with arguments. This is a basic location block. But there are some other cool bits that you can do with it. And I'll go into more detail into each one of them if I can. And just ask questions if I'm not being fully forward about things. So here's a really good example of... No, this will run for the base URL regardless of query parameter. Args actually is the query parameters. That would not get caught by that. So this is only for the top level. So that's like, I'll go into how you can actually customize what gets caught in these location blocks, and that's the power of the location blocks. So here's a really good example of, I put this on all my websites, obviously. A location block, Helgi is awesome, and I return 202 because it's accepted. So you can actually return specific HTTP headers back. So you could have done 301 or 400 or 500. You can return things. You can do other things within the block, and then at the end of it, you can say, oh, I want to return 301 because I'm awesome like that. But it just kind of shows what you can do with that. But the most important bit is to realize that it can accept regular expressions. You do that by adding the tilde in front of the regular expressions. And this is two really good examples of things that people do with their Nginx configuration. Denying access to all dot files. So you see here, there's the tilde and then the regular expression that we're dealing with. And down here, it's the backup files. This mic is really annoying. Whoa. So you just put the tildes in front of it without a problem. So that's how you can actually start augmenting your location blocks with cool regular expressions. You could have done tilde and then .php and then the $ to say, I want all files that end with .php, or I want all JavaScript files, or I want all files with a specific middle block. So we could have done a regular expression that only catches stuff with Helgi in it. So going onward from there, and we're going to kind of speed things up a little bit, is that the error pages. The error pages are quite interesting to play around with. This is the most basic error page that you can see. Error page, I want the 404, and I want that to point to this HTML file. But it requires the HTML file to be in the document root, the root that you define at the top. So you would say /var/dub, and then this file needs to exist in there. But there's a way past that. So this is a pretty common block that I do in most of my configurations. I define my root up here, and then I define an error block. And I say the location block of that is errors 404.html, but I actually keep that outside the public root. And by defining the internal parameter here, it will automatically return a 404 to people. So in this case, it will actually cause a circular dependency because we're already returning 404, but Nginx can deal with that. So if you wanted something to be only accessible by Nginx itself, you can just say this is an internal action. And that's useful in some cases when you're actually rewriting something to an internal secure download URL or a secure profile URL, but you want to be able to rewrite to it, but you don't want to change the actual location for that. This is the example of what I do with PHP when I want to process errors through PHP. So I just make sure the file exists, and then I include the fast CGI parameters, and that actually initiates the PHP, the FPM stuff coming together. So that means that if you hit a 404 page on my website, I can make 404.php actually process PHP. So you can do some cool stuff with PHP to go, did you actually mean that page? Or, oh, you seem to be lost. Do you want to log out? Or something like that. You can do this with any other HTTP codes. So in this case, I want to catch specifically all the 500 errors that I care about, and I want to do something specific with that because You want to show different pages if it's 404 or 500. You want to go, oh, you seem lost if it's 404, or oops, we messed something up. Our code monkeys are fixing it now. So you can actually manage these dependencies differently. Any questions so far, or just everyone bewildered? You guys hungover? Is that it? All right. I'll ask you guys some questions in a bit if you don't ask me questions. So it's quite interesting to deal with Facebook applications when you're in Nginx. So because my company, we're hosting PHP applications in the cloud kind of thing, we have to deal with people obviously hosting Facebook applications with us as well. So Facebook, in their whole splendorness, they decided to be more secure. So originally, when you have a Canvas application, they would do a GET request against your provided URL, and they would pass in all the user credentials through that. But that's insecure. So they started doing posts against the URLs. But the problem is Nginx doesn't really like posts against static elements, or just posts in general against the wrong thing. So what it would start doing is throwing a 404. Here, we're actually forcing the 405, or 405 that Nginx would throw. We're actually forcing that to be a 200, and we actually send people to this URL. The URI would be the processed version of the URL and the query parameters brought together. So URI means that it's been processed through rewrite rules and whatnot. So this is how you would have to do it. But as always, I had some clients that had to do things a little bit differently. So I had to come up with a new hack, which does things in a bit more complicated way. The reason was they were posting to a static element and then doing a JavaScript redirect, which is just not really cool, but Nginx would freak out if you don't do it like that. So we actually proxy the post request as a GET request against the same URL again. So you're just proxying the request, but you're translating post into a GET. So that's my hack to deal with that, because Facebook does their post against static elements. So that's kind of a nifty little hack that I managed to do just by proxying through the same server again, but changing the method. So the other cool stuff you can do is health checks. Who here uses Amazon, EC2 stuff? Only a handful of people. Do you guys use load balancers, ELBs? Okay. So when you have the ELBs on Amazon, or any kind of load balancer for the matter, you have to obviously check that the servers underneath the load balancer is still active. And you'd usually do that by just pinging TCP port 80. But that's kind of a vague check. It's just making sure that something is returning a 200. So I started doing, this is an Nginx only check. It makes sure that Nginx is up and running. So I just make it ping health, like health ping, and I return a 200. It just shows the ELBs that things are actually up and running, and you shouldn't actually terminate me. But then the complication came that what happens if Nginx is up, but FPM is down? There's no way of detecting that. But ideally, I want to recycle the box at that point, or at least figure out what's happening. So I kind of went into FPM and wrote this cool little config. So I created a new socket, make it listen to a different user. It's a static user, so like it's not scaling up or down with FPM. But the most important configuration bit here is the ping path. You tell FPM, listen to health ping, and you respond with pong. So you're actually telling FPM, without having to use PHP itself, respond with pong if you're still alive. So to combine that together, you create an upstream that points to the socket, and you're essentially doing the same location block as before, but we're including fast CGI, so actually FPM would get included. So what I got out of that is I can both check, is Nginx up and running, and is my FPM up and running? Did something crash my FPM? So you have the ability to do like kind of good introspection into your system through health checks like that. And that's just simple Nginx configuration. If you go on to the read-write modules, they're all regular expression as before. They're responsible for all the if statements that you've been seeing in my code before. They're responsible for any file checks, any returns. It's all the read-write module. And Nginx has variables that you can look up in the manual. There's too many to list here. But the URI would be an example of what the rewrite module actually handles. So if you think about Apache and the mod rewrite, that's a separate module. But with Nginx, it's tightly integrated into the configuration. There's no way you can't have it. So you can access things like URI, the user agent, the cookies, and multiple other things that you can access. And you can make decisions on the fly based on that. So when you're doing regular expressions, you do regular expressions that you do a regular expression, and then you have to define at the end, is it the last one, is it the break, is it the redirect, or the permanent? And those seem to me really confusing at first, and I'll show you some examples of that. But it's really important to understand that last means that you finish the rewrite, but then it goes back and starts evaluating all the other rewrites. So you do the rewrite, and out from there, another rewrite could rewrite that. So you can kind of create a cascading effect. If you do break, it means that you will do no more rewrites. It will just stop. If you do redirect, it's a temporary redirect, and a permanent means a permanent redirect. 301. And I think the best way to illustrate this is to figure out how do I actually forward domains in Nginx. So within my company, we have marketing people and SEO people and all these fancy short acronyms. And they were always, we need to forward the www version just to helgi.ws. Why? Because it gets me better SEO. So I'm like, all right, I'll make that happen somehow. I'll look into it. So I went through a few iterations, and this is my first iteration. I define a second server block. A server block is like a virtual host in Apache, right? So there's another server block completely below here that would say helgi.ws, no www. So this one is just for the forward. So what I do here is I say the server name, and I'm doing the rewrite. I do this fancy regular expression, rewrite the regular expression, what I want to rewrite it to, and then I define the permanent, because I want this to be a permanent redirect, so the browser realizes what's happening. But then I realized, well, this is kind of sketchy, because I'm trying to catch everything, and the $1 here is like in any regular expression, is the value of what you managed to catch. But I didn't like that. It's too sketchy. It's too brittle. It will break. So the next iteration I did, same thing over here, except now I just have the caret. So I'm just telling it, wherever it is, do a rewrite and use the request URI. The request URI is something Nginx has already found for you, so you don't have to try to catch it yourself. And again, I tell it to do permanent. So this is two really good examples of using the rewrite rules. But they're wrong for this specific example. And this is the correct way going forward, at least to me. So what I'm doing here, instead of doing any rewrites, this is still the rewrite module, but I'm just returning. I'm saying return the HTTP code that I wanted, and then I'm telling it, this is the URL you should actually return to. So it is actually doing a redirect for you. So I could have done return 200 and whatever URL, and it would have redirected me to that URL as well. But I want to tell people this is permanent. So this is the right way to do it, in my opinion. So I realized when I wrote these slides that I didn't have any actual PHP and Nginx configuration in there, because really this talk has less to do with PHP and more to do with Nginx itself. But I decided to throw in a little bit of what's my default configuration. So you define an upstream, and in this case, I'm pointing to the www1 socket from FPM. So in FPM, you have to configure, hey, here's the socket I want you to create, and out from there, you need to tell it, this is the upstream, this is the backend that Nginx is connecting to. So it's a Unix socket. But here, I'm doing a regular expression, and I'm telling it, all files that end with .php, and this is not the best way to do it because people can spoof the end to be .php. But anyway, this is the simplest way to do it. So over here, I'm telling it, check if the file we're trying to access, does it actually exist? So it's just request file name. And -f is a file exists check, and then the exclamation mark means if it's false. So in that case, I return a 404, and that bubbles up to my error pages. Other than that, I will tell fastCGI to pass any fastCGI requests to the web worker, and then tell it the index is index.php, and I don't want to intercept any errors. I want Nginx to handle that for me. Or sorry, I want that to bubble down to the application. And then the default parameters, the fastCGI parameters, or params, that's a file. So you're actually including a file there. What they are the parameters that we are used to seeing when we dump out the server global. So if you go into that file, you'll see some assignments back and forth. But I found it not to be as good as it could have been. So I decided to assign 2 of my own fastCGI parameters. So the script file name, I decided to use the document root and whatever parameters are passed in, the script name passed in from fastCGI. So I'm creating my own script file name. And I wasn't happy about the server name, so I decided to define that as the host that Nginx is processing. So you can actually define multiple hosts in the server location block. And I just want the server name to be exactly the same thing as what I'm processing right now, and that matches up with Apache. So this is kind of one of the more kind of basic PHP configurations that you can set up. But it works really well, and if you go out there and look through the blogs, you'll probably realize there's only about 3 blogs that do Nginx and PHP correctly, and everyone else is just copying them. It's kind of a funny world right now with that. But it's good. I like this way, though. So moving on to SSL, this is going to be a bit of a heavy section. SSL is really important. Don't kid yourself that you can just drop on an SSL key and it will just work, and it will be fantastic, and you don't have to think about it ever again. Here is my SSL configuration for Nginx. I'm going to break them down bit by bit, but in most cases, brain explodes, because ciphers are really complex. So let's break it down. The first one is pretty easy. You're just defining the certificate and the key. Next one is defining the protocols you want to support. In this case, I don't want to use SSL version 2 because it's vulnerable to things. Version 3 is as well, but not many servers actually have high enough OpenSSL version to support 1.1 and 1.2. So I'm giving myself a little breathing room there until the world of OSs has actually caught up with OpenSSL. This one here is kind of cool. This starts to define how much caching you can do. So you can do different kind of caching. There's the built-in caching that uses the OpenSSL one, but that one is kind of slow. So I just decided to use a 10 megabyte shared SSL cache. And that kind of speeds things up because it's caching the connections for me. And about 1 megabyte of shared cache can store about 4,000 connections. So the problem with when people are dealing with SSL, they sometimes just throw things on there and then start complaining, why is my website going slower? Well, because encrypting stuff is expensive. But if you do things like that, you're actually saving your server some work. The problem with the built-in version, instead of using shared, is that there's memory fragmentation issues that Nginx just hasn't solved yet. So who here heard about the beast vulnerability in SSL? Like one person? Seriously? Oh my God, you guys really need to go out there on the internet. So what it's all about is that it's a really serious vulnerability in SSL and how people configure their Apache and Nginx servers. So the problem is that specific ciphers, the CPC mode ciphers, can be exploited, and thus traffic can be decrypted. What this usually means is that I can record the traffic and then decrypt it afterwards. But it's not as serious as it sounds necessarily, but if you configure your server correctly, you can get past that problem. If you use the same configuration I'm using for the most part, you won't have that problem. But the issue here is that 75% of websites on the internet today using SSL are still vulnerable to this attack. And you can go to this website over here, trustworthyinternet.org/SSL-pulse, and it will give you statistics. So the combination of the protocols saying you prefer the server ciphers and using this ridiculously complex rule over here, you will get past this problem. The problem is that before, MD5 was preferred, and MD5 became quite vulnerable in the last few years. So what I'm doing here, this is an actual direct OpenSSL cipher rules. And anything with an exclamation mark, I'm saying I don't want that. So I'm actually saying I want fairly secure ciphers. But strong ciphers are quite slow, like I said before. But the good thing is there's something called the elliptic curve, which allows you to bypass a lot of the mathematical formulas that are required to calculate a strong hash or strong encryption. So in case someone in here is like a math nerd, they will probably appreciate this more than others. But these things are quite impressive because most of us know what a Diffie-Hellman encryption is. And that's used within most SSL connections today. But the problem is they don't do they do a key exchange to kind of get away with people can't decrypt your traffic anymore. Like, for example, I can record all the traffic on Facebook today, and if I get my hands on a hard drive from them 2 years from now, I can read all their stuff. But with my configuration, that's not possible. But Diffie-Hellman by default is so slow, and if you use the Diffie-Hellman elliptical curve algorithms, they're about 3 times faster. And you do that by defining the curve over here at the bottom. You're actually telling it to use a curve. So a 224-bit curve is the equivalent of 2048-bit RSA key. And this cipher over here, or this curve over here, the 521, is the equivalent of a 496 RSA key. So you can actually bypass a lot of processing. But moving on from the ciphers, from all the complications, and if this seems kind of heavy, I will put all these slides online, and I recommend everyone just to kind of look around and look at Nginx configurations to figure this out. But this is cool stuff because, it takes away a lot of heavy work. But another thing you can do is use the new strict transportation or transport security headers. So on your website, you can go do @header, and then you can define the header name, and then you can say, make it alive for a year and include all my subdomains. What it means that if anyone goes to your SSL website today, gets that header, their browser will know for the next year you should always go to the SSL website, even if the user accesses the HTTP stuff. So this serves as like an advanced redirect before they actually hit your website. But not all browsers are supporting this right now, but it's a really good one as well. So you can check your SSL ratings on sslabs.com, and if you go to the bottom and submit your website, you can do it anonymously so your website doesn't show up. They will tell you, oh, you have that problem, this could be better, you have a rating on 85 off 100. So you can get kind of a good idea of where you're standing with your website. So out from there, did everyone kind of understand that or just still kind of processing it? You guys are really quiet today.
You just showed me some example for @header, just the advanced redirection.
Mm-hmm.
But how do you solve when people entering the site without HTTPS or SSL, but you need to redirect them to the SSL site, and you don't have a multi-domain SSL certificate, so switch between domains.
So you have to switch between domains. You do that. So he was asking how do you redirect people from HTTP to HTTPS before they get this header, essentially. That's the question. Yeah. So what you can do is essentially use the same approach that I used for forwarding www to a non-www domain. You just do exactly the same thing. I actually may have a code example of that I can show you guys a little bit further on. But you can use things like there's the schema variable that figures out, oh, you're in HTTPS or you're not in HTTPS. So you can do a lot of matching. So if I can't during the talk. I can show you after the talk a code example of that. So the headers, the last slide here started talking about add headers. So let's dive into headers because they can be quite handy when you're dealing with your website. So the default header module in Nginx provides add headers, and in this case, I'm setting a cookie. In Orchestra, you can actually bypass the caching layer that we have by defining underscore orchestra equals 1. In this case, sometimes when I get 404, I don't want to cache them. So when I say, hey, you're in the 404 block, I actually add this kind of header to make sure my caching layer is not catching a 404 that might actually resolve itself within 20 minutes or so. So that's a good example of how you can set a cookie. But then it also has expires. So in this case, I'm telling it to take all images and JavaScript and make them expire in 1 hour. That's the equivalent of telling the browser this should stay alive for 1 hour. You can tell it max, which takes it as far in the future as possible. You can do epoch, which takes it as far in the past as possible, so it never expires. But the built-in header module is kind of limited. So you can actually compile in a better header module functionality. And it's a long URL, I know, but just get it from the slides afterwards. So in this case, there's a lot of code, I know. But in this case, it allows you to do it's more set headers, and you can change the server stuff. It's actually allowing you to overwrite stuff. Over here, we're actually clearing out headers. We're actually deleting headers. So we can actually control what headers get sent to your backend or your caching layer, or, oh, I don't like that cookie, I'm going to delete it. You can do -t, which defines the type. If the type matches CSS, we want the content type to become foo for some reason. -s means that if we match that status code, we should be doing this or that, or we should transform it to a different status code. So it allows that header module to do a bunch of cool things. In this one, these were output headers, things that you're returning to the customer. These are input headers. So actually, when I wrote this, I was in Chicago at another conference, hence a few of the different names here. So I'm setting the input headers. I'm changing the host of the user. So I decided that the host is not correct, so I want it to look different. I'm changing the input header of what they sent me. And then I decided to replace the value again. So it's input headers versus just set headers. So it's when you're playing around with what the user sends you versus what you're sending them. So you can be manipulating what your application is doing, but at the Nginx level. So headers can be quite useful. But Nginx can do load balancing as well. And it does it fairly well. It may not be HA proxy, but it does it really well. And within Orchestra, we use some Nginx load balancing. So the simplest one you can do is round robin. You just define a bunch of upstream web workers, and in this case, I was just using the domains to just say, hey, there's 4 servers that I want you to load balance between. And it will just go, I'll just take whichever one I can find first in a round robin fashion. But that doesn't really give you a consistent hashing. And what that means is that if I go to ww1, my next request could go to number 2, and then 3, and then 4. So it's not sticky. So to solve that, you can use IP hash that allows you to do consistent IP routing, which means that if I go to number 1, I will stay on number 1. And that's really important when you're dealing with sessions. Ideally, when you're dealing with multiple servers, you should have sessions in Memcached or similar, but this will allow the user to hit the same server over and over again. So if you're uploading something, and you save it on that server, and then you make it propagate throughout your cluster, they will keep on seeing that picture until they get a new IP, essentially. But the thing is,
unless we have suppose a shared session server.
Sorry?
This will work, and we need this with hash IP, unless we have a shared
Yes, I mean, that's how PHP works, is that if you hit 2 different servers and 2 different requests and there's an important session like login or some similar, it would not otherwise persist across servers. So if you are using a simple load balancing with round robin, you'd have to save the PHP session into MySQL, Memcached, or similar. Otherwise, the user just doesn't stay logged in. But that's just the side effect of how PHP is built. So the thing is, when you're doing load balancing, sometimes you want specific servers to have more predominance in your cluster than others. So you can use different weights. So what it means that the top server has a weight of number 1. Number 1 is the default. Weight 2 on the second one means that it's twice as likely to get traffic. And 4 means it's 4 times as more likely as the first one to get traffic. Then you can also define fails. You cannot redirect there. And it will try every 10 seconds to send people there. And if it fails, it will then just try to route you to a different server. So there are timeouts, 15 seconds, 2 fails in 15 seconds. Then we consider that server kind of out of rotation. Before, wait and IP hashing could not be used together, but now it can. And it's only the newest development version that was released like a week ago, or less than a week ago. They also added what they call least connection. And that's a brand new load balancing module, which means that it will actually try to send people to the least loaded server, or that has the least amount of connections to it. So that really improves how Nginx can actually deal as a load balancer. So going on to caching, like turning Nginx essentially into Varnish. We do that. We do a lot of that at Orchestra, where we have caching servers for people. So here's a really simple caching setup. I'm setting a lot of proxy options, and there's so many proxy options that I couldn't go through all of them. I think there's easily 40 of them. So you'd have to look up the documentation for some of that. But what we're doing here is we're actually setting a header because I want the remote address, as in the remote IP of the user, to be sent along, but as the X real IP header. So my application can go, oh, okay, that's the real IP. You need to set the X forward 4, which most PHP applications depend on from Apache. And then you're setting the host, and that's just the HTTP host of the user. So you're actually forwarding on some of the details. But the proxy cache path is the most important one. So in this case, I'm actually telling it to go into dev shm, which is the memory, under Nginx. Levels 1:2 means that it's saving into a deeper directory structure, so we're not hitting any sort of slowness by having too many caching files in the same directory. You can go down to level 3 as well. So it just means that the directory is named A/B/ and the cache. In this case, it's just like A and then cache. The temp path, you're telling it, hey, anything that you need to save in as a temporary file, I'm just telling it to save it into memory as well. And the last one there, proxy cache use stale. When I say updating, I'm telling it, only one of you guys go and try to update the value. The rest of you guys go and just serve stale data. That allows you to defend against slamming from all the connections from the users to your backend server. And in this case, I'm just defining a server block. So this is the HTTP block, the governing block. And this is the virtual host. And I'm just telling it, pass anything through to this if you don't have a cache. Otherwise, listen at the my cache, which I define here, at 8 megabytes. So 8 minutes. The cache lives on for 8 minutes, and the max size is 2 gigabytes. I'm only willing to go up to 2 gigabytes. So over here, you're telling it the cache is valid for 200 and 302 response for 60 minutes, and a 404 is only valid for 1 minute when you're using this proxy approach. So before, when I was talking about the more HTTP headers, we have to think about how do I actually compile that into Nginx without being a pain, because it doesn't really sound all that fun to be compiling stuff into your web server. It's fairly easy as such, but you have to have compiled Nginx to begin with. So you need to actually go into the source and basically tell it configure and point to the new module that you want to add. So in this case, that would be the header module that we're dealing with before. So that's how you add in new modules. For example, a lot of the cool stuff is a third-party module, like some of the Memcached stuff. You can do Redis, you can do like streaming stuff, chunked HTTP, and a few more things. But let's do a little bit of blue sky thinking, some of the more advanced stuff, I guess. So if you think about Memcached and how traditionally people would use Memcached, is that Nginx gets a request, you drop it into PHP, and PHP goes, does Memcached actually have any values, or does it not? And then, based on that, it will either try to generate the content, return it, or get it from Memcached. But with Nginx, this only works for GET requests currently. If you get some of the more advanced Memcached modules, it can actually write to Memcached as well from Nginx. But in this case, Nginx gets a request, it will pass it to Memcached and go, do you have this hashed value that I'm looking for? And if it does, it will just return directly without touching fastCGI. Otherwise, it will be passed through to PHP and returned to Nginx. So you're actually, in some cases, or in a lot of cases, depending on your application, you could be cutting PHP or Ruby or whatever you're using out of the request loop. And here's a fairly simple version of how you use Memcached with it. Most of this is boilerplate code, so really what we need to be focusing on is this bit here. Everything before is going, oh, this is not a GET request? Well, then I'll pass you directly through to the fastCGI portion. If it's a JSON file, I want to rewrite it into a specific format. If it's XML, same thing. It's to get the MIME types kind of copying on and actually doing what they need to do. Is it HTML? Oh, I actually need to tell you that this is the content HTML and set the UTF-8 and all that stuff. But the essence of this one here is you're setting the Memcached key to Nginx prefix whatever you want. Like it could just be called herp derp derp and then URI. So you can actually build out the key. And Memcached passed, it works the same way as the upstreams. So the Memcached stuff is just an upstream. And you're just referencing that upstream over here. And it's saying, if I get any of these error pages, we fall back on fastCGI. Otherwise, we'll try to return it. So that's kind of interesting to be able to bypass your language and just code that into Nginx. In some cases, it can actually speed up your site quite a bit, depending on what you're doing, because you don't have to drop into PHP and FPM at the same time. So I don't have any more examples, but I have these two last slides that I kind of want to talk about. And I found this quite interesting, is that in Nginx, there's a third-party module called MySQL, or Drizzle, actually. And it allows me to write direct queries within Nginx to fetch data. So what I could do is make Nginx talk to Memcached, then fall back on trying to get some specific data from MySQL, depending on what kind of request it is. Obviously, you can't do transformations, but you can fetch data. If that's fine, it's cool. And then there's another module that works for MySQL and Postgres and whichever database there's a third-party module for, which can take that data and transform that into JSON or CSV output for you. So you use that module, so you can combine these three modules to effectively create a chain to then end up with JSON output again, and you can then save that into Memcached. So it's quite interesting to be able to almost create a whole application, granted, only for the caching portion of it, but you can make Nginx basically self-sufficient for fetching the cache. So to me, that's quite interesting, and I've seen speed-ups of a factor of 400%, depending on what they are. But that's kind of my blue sky thinking on that. There's a lot more of that out there, and you can just look through the modules, and you can do so much cool stuff with it. For example, one of the coolest ones I was playing with the other day, you can actually do Lua coding directly in Nginx. Depending on if you like Lua or not, that might be cool or not, but I liked it quite a bit, that I could actually script stuff within Nginx to then perhaps manipulate specific bits and pieces of the data that I'm dealing with. So we're kind of at the end of the talk, and we're anyway at the end of the 45 minutes. So are there any questions from you guys? Do you guys want me to explain something better or differently?
When you did the health check and you set up the separate socket for it,
Mm-hmm.
do you find any benefit of doing that over just having your health check fall through the same rules that your actual application?
Okay, so this is a really good question, actually, and we had this with Orchestra. So he was asking, why did I do a separate health check socket as an FPM socket for the health check and go through that instead of going through the same socket that an application goes through? So the way it works in FPM is if you're slammed with traffic, they will just try to serve that up as they get the requests in. So what can happen if you have it on the same socket is that the load balancer doesn't get a reply quickly enough and will consider the server unhealthy. The server might just be replying a little bit slower, but it might not be unhealthy either. So you want to get past the situation of your server being torn down just because it didn't respond within 5 seconds a few times in a row, but in reality it was just actually trying to return it in 7 seconds. So it depends on how much you actually value your servers to stay around. So we ended up, FPM is a little bit broken. So sometimes I would see it spike traffic or spike CPU quite a bit. But overall, we found it more stable to keep a separate socket. They're living under the same master, so if the whole FPM thing crashed in any way, we would still get notified because the health socket will die with the main socket. So that's why I tell it, you're static, you're only one worker. You'll restart yourself every 10,000 requests. So it gave us a bit more stability, and it didn't actually start imploding servers right away. So that's the reason why we did it, because we actually had customers so slammed with traffic, and FPM would actually take a while to respond, and we ended up with this cycle of, we have so much traffic, we need to scale up. But at the same time, our load balancer was scaling up and then tearing down old servers. So we just ended up with like constantly trying to catch up, and you just don't want that when you're actually overloaded with traffic. So hopefully that answers that. Other question?
Same deal about health checks. I saw you return Pong. Is there a way to validate in Nginx that the exact term that was returned was Pong, so you can see all the output is?
Yes. Yes, you could. You can actually take the response of, so the question was, FPM, it returns Pong, can I make Nginx validate that as well? So the reality is that your health check is just looking for a 200 back. Whatever that is, doesn't really matter. But Nginx does have the ability to take the response from fastCGI, and then you can do stuff with that before you actually respond that back. That is a bit more advanced stuff and can get a bit hairy, to be honest. You don't, like, too many if statements and too much magic in your Nginx configuration can be amazing or can hurt you, depending on how well you actually know Nginx. If you talk to the Nginx core developers, they despise if statements. It's the worst thing in the world to them because it's extra processing. It takes more CPU, essentially. So, any other questions? No? All right. So you guys can email me any Nginx questions that you have in the future, and I'll be more than happy to help you. You can tweet at me. If I can actually read my reply stream, I will reply back. You can catch me later on or at the social tonight and ask me any questions. Specifically, if you give me a drink, I will answer even more questions. Huh? Well, that's extra. But myself and the organizers would really appreciate if you went to the joined-in URL and actually rated the talk. I will upload these slides and I will link them from the talk. I will do it as soon as I get a half-decent connection and speaker deck actually converts the whole thing. So the slides will be available at this URL. So please go there to find the slides and rate the talk if you liked it, or tell me if you hated it. Either way, it's great feedback. Thanks a lot, guys. See you at the social later on.
DPC Radio is a production of iBuildings. The materials presented are copyright of the speakers. This episode is released under a Creative Commons Attribution, Non-Commercial, No Derivatives 2.0 license. iBuildings is a full-service web development company specializing in PHP development. For more information on how we can help you with your next web project, visit our site at ibuildings.com. Thanks for listening, and we hope you'll join us again for DPC Radio.